You had to fly your fuel in, and we needed in the order of 100 to 120,000 liters each season. And this meant that the aircrafts were in a situation where we had to fuel them with something which was in the price level compared to normal red wine.
Welcome to Polar Podcasts, where you'll hear stories from geologists who've spent their careers, their lives, exploring and studying the remarkable and remote geology of Greenland. Why did they become fascinated with Greenland? What were the problems and the discoveries that drove them? And what was it like working in these remote places where few people venture, even now? I'm Julie Hollis. In this episode, we hear more from Niels Henriksen, Emeritus Senior Scientist at the Geological Survey of Denmark and Greenland, about his years spent mapping the Caledonian Fold Belt, an ancient mountain belt in remote northeast Greenland.
East Greenland geology is very much different from West Greenland. The main object for the work we did in East Greenland was work around the Caledonian Fold Belt, which is a fold belt which you can follow in East Greenland from the Scoresby Zone region where we started and all the way up to the northeasternmost part of northeast Greenland.
The Caledonian Fold Belt is an ancient mountain range formed about 400 million years ago when Scandinavia and East Greenland collided.
That's a long stretch, and if you compare that with the topographical map of Britain, then putting the southern part near to the English Channel, then the northernmost part of northeast Greenland would compare to some position north of the Orkney Islands. So it's a really fantastic region. At that time we had to do a lot of work there, following our observations from the Scoresby Zone region. We continued the work in northeast Greenland, first in the northern sector, which was to the north of where the Lauge Koch group have did their work.
As Niels explained in an earlier episode, Lauge Koch was a Danish geologist and explorer who did much of the early geological and topographic mapping of East Greenland.
So they already had some scale 1 to 250,000 mapping, but this only was up to 76 north, and everything between 76 north and 81 north, that was not covered by any systematic geological mapping. When we were finished in the Scoresby Zone region, we started with the work to the north of 76. And then we did it in different tempos. First we did the southern part of that. Then we made an interval and pause where we did the geological mapping in North Greenland over 2 periods. And then we returned again to the northernmost part of northeast Greenland and finished that. So we had full coverage of everything to the north of 76. And then at the very end, when we were finished, all of northeast Greenland and North Greenland, we returned and remapped the region where the Lauge Koch group have worked in central East Greenland. That was between 72 and 74 north. Besides the Caledonian Fold Belt in northeast Greenland, we also have the same sedimentary sequences as we had in the Scoresby Zone region. So this means that we had sediment deposited from the Carboniferous, upper part of Devonian as well, and all the way up to the Quaternary.
This covers the geological time period from about 360 million years ago, all the way through to just a couple of million years ago.
Therefore, we had divided the groups working there, as we did in the Scoresby Zone region. We had sedimentologists and paleontologists who worked with the sediments in the outer coastal regions. There was a group also who were working with the tertiary basalts, also in the outer coastal region.
The Tertiary, a term that is now subdivided into the Paleogene and Neogene, is a geological time period from 66 to about 2.5 million years ago. Mainly the early part of this period, the Paleogene, saw huge volumes of basaltic lava erupted during rifting of East Greenland from Scandinavia and the opening of the Greenland Sea.
And then the inner part of the complex was exactly the same as in Scoresby Zone. That was crystalline rocks.
That is, the igneous and metamorphic rocks.
That was filled out with Caledonian rocks, which were formed during this fold belt formation at about 400 million years ago. The Caledonian Fold Belt is formed by a collision between the two sides of the North Atlantic, the continents to the east and the continents to the west. And by this collision, they have, like in the Alps, formed huge thrust complexes.
A thrust is a fault or break in the Earth's crust, where older rocks are pushed up over younger rocks. A thrust complex is where several thrusts are stacked, one on top of the other. This is common when continents collide and mountain ranges form,
which included not only the youngest part of the sediments before the Caledonian fold bed, but also included all the basement complexes. You had the former Precambrian basement to the sediments, which was deposited on the basement. So you have a very complex structural situation in the thrust belts in northeast Greenland. The thrust belts there, we really first realized at a quite late stage. We had the opinion that we had these thrust belts, but it was not easy to prove because at that time we didn't have the proper criteria for demonstrating the existence of these huge thrusts. But to the north of the Scoresby-Sund area, at the end, we found that you had older rocks being thrusted upon younger rocks. We had criteria indicating for us that the younger rocks containing fossils, which were Cambrian and Ordovician fossils.
That is, fossils of creatures living between about 540 and 440 million years ago,
were simply over-thrusted by crystalline rocks which came from the deeper parts of the Caledonian fold belt and which had ages at about 1,000 million years. The 2 last years in the Scoresby-Sund region, we were without a big ship as a floating base, and therefore we had to reorganize our logistic backgrounds. Therefore, we established tent base for the main group. Everybody was flown from Denmark to Greenland. We had an airport at the old lead mine in Mestersvig, and then we got a small aircraft to help us with the internal aircraft support. We found a operating system with establishing our own small airstrips around every time we found a flat area. We put our markings of these small landing areas. We had airplanes which could land in very short distance. These airplanes called STOL, S-T-O-L, short take-off and landing. This means that you could come down with the aircraft landing and a gravel strip which was no longer than 250 to 300 meters. Over the years when we worked in northeast Greenland and North Greenland, we established simply a system of small landing strips. We prepared them with simply leveling the ground with shovels, took away all the big stones, and then we marked those airstrips. So at the end, after our work, both in North Greenland and Northeast Greenland, together with the Sirius group, which was a military sledge patrol people.
The Sirius Patrol is a Danish military unit that carries out long-range reconnaissance of remote northeast Greenland using teams of 2 travelling by dog sled.
Then we have established ourselves with about 50 small landing strips all over. So with this aircraft, we had the possibility to cover most part of northeast Greenland and North Greenland. We had a very fortunate situation in the area because all over in East Greenland and North Greenland, we have a fantastic good exposures.
This means that the rocks are exposed at the surface with virtually no soil or vegetation covering them, making it easier to see and interpret the geology.
Northeast Greenland is a fantastic place to work as geologist because you have a unique exposure. You have a possibility to view the fold belt formation and also the formation of all the sedimentological sequences in a 3-dimensional way. You have exposure which is, I would say, in the average between 50 and 80%. That's fantastic. In general areas in Scandinavia, you have no more than maybe 5-10% at the most. Sometimes it's even less than that. In West Greenland, it is very much less than in East Greenland. And then you have the possibility to view things in a 3-dimensional situation as well, because you have exposure from the sea level and up to the mountain tops, which is nearly 3,000 meters. And on good days, you can sit down and view things at a distance between 100 and 200 kilometers. So you got a possibility to use the aerial photographs and long-distance observation. You could record a lot of geology combining observations from aerial photographs, binoculars, and then groundwork, where you're like on the west coast, you simply walk walk around from the small camps you have. You had the same general system. You shifted the base camp, which were 10 base camps every year. And then you had all the geologists working around base camp in a circle which is up to 150, maybe 200 kilometers away from the base camp. And then you shifted the base camp with intervals of one new base camp for each season, or maybe sometimes 2 seasons in one base camp. But generally you shifted base camp every year. We had support with the helicopters. We got sometimes 2 helicopters, sometimes 3, and we shifted helicopter type. The small helicopters which we used on the ships as a floating base was shifted with newer helicopter types which were able to fly faster, climb much better. They have also much better payload. They were not working with pistol engines like the only small helicopters we had in the beginning. We shifted from helicopters able to lift maybe 300 kilos into helicopters which could lift maybe 500 kilos. Then you could have camp with 2 geologists and all their equipment in one load of a helicopter. With the small helicopters you sometimes had to go 2 times to shift the geologist camp. This is not necessary with the newer helicopter types. There you could simply take it in one lift. Transport to and from Greenland was of course a must. And no infrastructure in northeast Greenland. You had only 2 possibilities to get in. That was via the gravel airstrip you had at the old lead mine in Mestersvig, and then the other was at the former weather station called Station Nord. We based our transport in and out of the region by help of the Danish military, which had their long-distance transport machines called the C-130, Hercules transport, which was propeller machines which could land on those gravel strips we had. And then we mainly got, in the beginning, our fuel sailed in drums from Denmark by the ships, but there are very few possibilities to get fuel into East Greenland with ships once or twice every year with the ship, because you have the ice outside the east coast, which is more or less blocking the coast all the year round. You only have a window of about 5-6 weeks where you could sail into East Greenland. This means in practice that there is only 1 or 2 times a year where you can get a ship into East Greenland. With the ship connections you got possibility to take fuel in, but in the very north where you can't get ships in, you have to fly your fuel in, which means that fuel is very expensive in both North Greenland and the northernmost part of East Greenland. You are flying all the fuel in. We had a system of flying fuel in which was based on taking it in with the C-130s, mainly as bulk in tanks on board the C-130s. This was flown into either Mestersvig or to Station Nord. There it was put into the tank system they had on these bases. From the tank system, we pumped it into a small tank system in the Twin Otter, where you could have about 1,500 liters in each go, and then you flew it from the landing places in Station Nord, for instance, or Mestersvig, out into our tent base camps with a number of flights with the Twin Otter. We needed in the order of 100 to 120,000 liters each season, so it was quite a burden. This meant that the aircrafts, the helicopters, were in a situation where we had to fuel them with something which was in the price level compared to normal red wine.
I'm Julie Hollis, and you've been listening to Polar Podcasts. In the next episode, we hear from Bjørn Thomassen and Kent Brooks about their discovery of the Flammefjord molybdenum deposit while working for the Nordic Mining Company in 1970.